As I mentioned in the last video, I wanted to take a little bit of time to begin to speak about the software that operates the Arduino microprocessor. The software is open source, Arduino IDE. It's based on a C++ programming language. We'll get into the basics of how it works shortly. I just wanted to point out that there's excellent resources online for this. It's one of the things that I really appreciate about using the Arduino. It's a very user-friendly resource in that there's a lot of support out there. The website has reference material, it has examples of code, tutorials. There's also a very active forum in which you can post your questions. So let's go ahead and open up the Arduino program here. I wanted to start by creating a new sketch. And so we're going to go up to File, we're going to drop down to New and create a new sketch. Typically what I like to do is start by naming it. And so to do that, we're going to again go to File, drop down to Save. And for this one, let's do a program in which we turn an LED on and off. Maybe I'll write my last name, underscore, and then let's call this LED test. Okay. Before we really get into the details of the program, I just wanted to speak briefly to the overall layout of the program. And there's really three parts. There's the section that happens before your void setup. There's the void setup itself, and following that there's the loop. And these three sections do different things. Before we set things up, we need to establish what's actually in the program, what's connected to the Arduino, what names we're going to be referencing throughout the program. If we're importing code libraries for specific things, let's say a motor controller, we would do that in this section here. We were going to turn an LED on and off. So we need to communicate to the Arduino board that there's an LED attached to it. So we're going to do that here. We're going to write in int, and then we're going to call our LED light LED pin. And just to kind of explain what's going on here, int or int is a type of data type. And there's different ways that this could be written. Writing code is in a sense like cooking. There's different ways to get to the same result. Int is just one specific type of data type. The name that we've chosen that follows that, it could be whatever you want to make it. In this case, we called it LED pin because we're working with an LED that's attached to a pin. It's a nice simple name. I do want to point out one standard practice within coding. It's not something you have to do, but it's a standard practice, is that if you are using a name that has more than one word in it, the next word that comes up is capitalized. So in this case, it's LED pin, the P is capitalized. If we were to write a green LED pin, you would write it like so. Not something you have to follow, but it's a standard practice. However you decide to program, the advantage of having a consistent way of doing it is that you'll be recalling these names throughout your program, and the more complicated the program, the more likely you are to forget exactly how you've written it. And if you capitalize one thing and you forget to capitalize it somewhere else, it won't recognize it. And so it's good to have a consistency to the way you choose to do things. So we've now given the LED a name. We've described what kind of data type we're going to use to hold that information on the Arduino. Now we need to tell it where it actually exists. And so we're going to say equal 13. The 13 points to the fact that it's connected to pin 13. And you'll see that we added a semicolon to the end of this. The semicolon acts in a similar way that a period would work on the end of a sentence, in that it tells the Arduino that this is the end of a statement. And you can imagine if you didn't have a period in the end of a sentence, it just kind of blends into the next, and it gets quite confusing. With the program, it's the very same thing. If you forget to add that on there, one line leads into the other, and computers are a little less forgiving in doing guesswork. I think if you're reading, you can make guesses that there's a period missing. Within software, it's very important the way we add syntax to things. But we've now established that there's an LED pin on this board. That's kind of the setup. In a way, it's like setting up your workspace or setting the table. The next thing we do is drop down into setup. You'll notice that there's already a description here, some comments that says put your setup code here to run once. You'll also notice that this sits in between two curly brackets. The curly brackets serve to, they're almost like bookends. And there's an opening curly bracket and there's a closing curly bracket. You always need to have them working together. If you're missing one, the program's going to run into problems. In a similar way to a missing semicolon. We have our opening bracket is telling the Arduino that this is the beginning of this section of code. This is where we need to tell the Arduino what we're going to do with the pin that we've just put in there. So we're going to write down pin mode, and you'll notice that the color of the text we just put in there is changed. The reason it's changed is because it's part of the library of information that's running in the background. It's a code word that it recognizes. What it does is it defines how that pin is going to work. That pin, we're going to set it up to output. So we're going to put down the name of our pin. We've called it LED pin, so that's what we write in here. We put a comma and we're going to set that to output. And just like before, we need to put a semicolon on there to allow the program to understand that this is the end of that statement. After that, the program will run to the end of the curly bracket, which communicates that it's the end of the setup. It's kind of run through this once, and now it's going to go onto the loop. So the setup is almost like we've brought the material onto our table or into our workspace. We've now organized it, and we're ready to move on to the loop and to actually work within that workspace. And so this brings us to the loop, which again has a curly bracket to open it, and you'll see when I highlight this, it also highlights the closing bracket. And this is where we're going to enter in the code and begin to make the LED do stuff. Okay, we're going to have it turn on and off. So we're going to write in a different word here, digital write. Again, you'll see that the word write, capital W, that's kind of standard practice in coding. If you were not to have that capitalized, it won't recognize the word as a command word, so you have to make sure that you have that correct. So we're going to digital write the LED pin, so we're again recalling that name, and we're going to set it to high, which is basically saying turn on. We put a semicolon on there, saying that it's the end of that statement, and then we're going to set a delay to this. With the delays, it's running in milliseconds. And so 1,000 is equal to 1 second. And so we're going to put 1,000 on that. And if we were to leave it here and run the program, what would happen is it would recognize that there's a pin attached. It would set it to output. And then as we drop down to the loop, it would turn the light on. It would delay for a second. And then it would start up again. It would turn it on. Well, it's already on, so it's just going to stay on. So let's turn the light off again. We'll put a digital write. And then we're going to recall that name again, LED pin. We're going to set that to low, which is going to turn it off again. If we left it here, it would turn off for a split second and then go back up to the top of the loop again, turn it on, so you wouldn't even see that. So we're going to add another delay to this as well, of another second. And now we're ready to upload this to our Arduino. So I'm going to switch over to a different video. We have our Arduino here, and we're going to plug that into our computer through the USB port. And we also have an LED. So you'll notice with the LED there's two leads on this. And the one lead is slightly longer than the other. The longer lead is the positive, and the shorter lead goes to ground. And so we're going to plug that into our Arduino. The convenient thing, and the reason that we've chosen pin 13, is that it's right next to ground. And so we can put the ground pin, the short pin, into ground, and the long pin into 13. And you'll see that this is blinking on and off. One thing I wanted to point out too is that when uploading, as I mentioned in the past video, there's a lot of different types of boards. And so you need to choose the board and the USB port that's going to be connected to your Arduino. And so if you open up Tools and you drop down to the type of board, we've already selected the type of board that we're using. And if you're using a different board, you simply choose another board. Another thing that is important to do is to drop down and to choose the correct USB port so that you can upload to your Arduino. If you're using the same one, these are going to be established from the previous session, but you may need to change those depending on the type of board you're using or if you're using a different USB port. We now have our flashing LED. It's turning on for 1 second, turning off for a second. Let's go back to the programming and manipulate that a bit, just so we understand how this is working. Why don't we take a 0 out of each? And so instead of it flashing once a second, it's going to be flashing once every 1/10 of a second. And we're going to go back up to upload, which is the arrow there. And you're going to see that it's compiling the sketch. It says it's uploading it, and the uploading is done. So if we look back to our video again, you'll notice that the LED is now flashing at a higher rate. So we'll leave it at that. That's kind of the basics of an initial test. We'll move on to look at how a sensor might be introduced into the mix.